In the previous class, we learned time domain analysis of Hilbert transform. In today's class, we study frequency domain analysis of Hilbert transform. Here, we consider that Fourier transform of x of t exists. Therefore, the block diagram in frequency domain is written like this. Input x of t is having Fourier transform x of f. H of t system response is represented by Fourier transform h of f. Then output y of t, which is in time domain, after applying Fourier transform represented in frequency domain, that is given by y of f is equal to x cap of f. So with this block diagram, we can write the expression for output y of f is equal to Hilbert transform of x of f in frequency domain, that is given by x of f into h of f. That means in frequency domain we are multiplying, and convolution in time domain we are multiplying in frequency domain. So taking Fourier transform of this h of t, that is nothing but 1 by pi t, results in frequency domain minus j signum function. So rewriting this expression using signum function, y of f is equal to Hilbert transform of x of f is given by x of f into Fourier transform of 1 by pi t. Substitute this expression, y of f is equal to x of f into minus j signum function. So what is signum function here? Signum function is defined in mathematics by this expression. For positive frequency, we have amplitude plus 1, and for negative frequency, it is minus 1. So, by substituting this value of signum function here, we are able to find the magnitude and phase spectrum of this factor, that is h of f. So if you take modulus of h of f, it results in unit magnitude, and if you take the phase spectrum of h of f, it is given by minus j signum function. You substitute signum function here. The values for frequency greater than 0 plus 1 results in minus j, and for frequency less than 0 results in plus j, which indicates that positive frequencies are having negative phase shift and negative frequencies have positive phase shift. So this is the frequency domain analysis of Hilbert transform. Now let us understand the properties of Hilbert transform. There are 6 properties. The first one is x of t and its Hilbert transform have same energy density. Second property is about orthogonal nature. X of t and Hilbert transform of x of t are mutually orthogonal. Third property is taking Hilbert transform twice on x of t results in negative sign, that is minus x of t. In a similar way, fourth property is about autocorrelation function. X of t and Hilbert transform of x of t have same autocorrelation property. Fifth one, all positive frequencies have negative phase shift and negative frequencies have positive phase shift. And the last property, Hilbert transform of the message signal and the carrier signal when you multiply results in message signal into Hilbert transform of carrier signal. Here message signal represent low frequency and carrier represent high frequency. That indicates that If you multiply low frequency and high frequency, take Hilbert transform, results in Hilbert transform of the high frequency multiplied by the message signal. So we'll try to prove the properties in the next class.